Have a nice day, children. A healthy day for everyone. In the face of the current epidemic, schools as well as tuition classes have been completely disrupted. So I thought I'd do something useful for you. Children, first you listening to my video lesson and then do the relevant exercises in your textbook. Later listening to video again and learn the lesson. If you need, repeat this for several times. I hope to start from the first lesson in the third term. I put the recorded lesson into your group once a week. Ask your friends also to join with this group and learn all the mathematics lessons and hope the paper discussion also in the future. Well, let's start, children, from the first lesson in the third term. The first lesson in the third term is, children, inequalities. Inequalities is the 21st lesson in your textbook. According to the textbook, children, inequalities is in your third book, third lesson, third term, first lesson. According to the book series, inequalities is 21st lesson. Then what's mean by, children, inequality? See how we build up inequalities. To explain this, children, lesson, let's discuss first about equations. Equations. What's mean by, children, equation? You can join, children, two terms or a term and an expression or two expressions using an equal sign. Then you can build up equations. For an example, x is a term, phi is another term. Joining these two, children, using this symbol, we can form equation. Then x equals 5 is an equation. Joining two terms using an equal sign, we can form equation. Another example for equation, children, 2x minus 1 is an expression and 10 is a term, non-term. This is an expression, this is a term. Joining these two using an equal sign, we can build up, children, equation. Another example, 2x plus 1 is an expression and x plus 10 is another expression. Joining these two expressions using an equal sign, we can build up equation. Then to build up, children, equation, you have to join two terms or a term and an expression or two expressions using an equal sign. Then joining two terms or a term and an expression or two expressions as above, we can form equations. And then these are example, children, for equation. Now let's move on to our lesson, inequalities. Inequalities. Right. Now we can join, children, the above terms or expressions using an inequality sign. And inequality sign, we can build up inequalities. Or joining two terms or a term and an expression or two expressions as above using the inequality sign or using the following symbols, we can form, children, inequalities. This symbol is called, children, greater than. Greater than. This one is read as, children, greater than or equal. Greater than or equal. Another sign, children, this one, less than. less than. This one less than or equal, less than or equal. Then using two terms like this, or a term and an expression, or two expressions using one of these symbol, we can form children inequalities. Example, x is greater than 5. How do you do this, children? X is greater than 5. Next one, 2x minus 1 greater than or equals to 10. Next example, 2x plus 7 less than 2x plus 10. Then one more example, children. 2x minus 7 is less than or equals to x plus 8. Then joining two terms like this, or a term and an expression like this, two expressions using one of these symbol, children, we can build up inequalities. Then these are equations. We use this symbol to form equations, and using one of these symbols, children, we can build up inequalities. Clear? Right, now let's learn, children, how we solve equations. Before we learn to solve inequalities, let's recall your memory on solving simple equations. Third subtopic, children, solving simple equations. Let's learn how we solve simple equations. Right. Question, you write down the question. Solve the following simple equations. Solve the following simple equations. First question, question number 1, children. X plus 2 equals 7. In solving this equation, children, use subject x now. In solving this equation, use subject. You find x. To find x, children, you need to get this positive 2 from left to right. When you get positive 2 from left hand side to right hand side, it becomes negative 2. Then 7 minus 2 is, children, 5. Then x equals 5. Second part of the question. Second example, x minus 3 equals 8. Then x equals, you have to get this minus 3 from left right. It becomes plus 3. X equals 8 plus 3 is 11. Then example number 3, 2x equals 12. When 2x 12, children, x equals 12 over 2. Divide 12 by 2, x equals 6. Fourth example, fourth question, children. Question number 4, x over 2 equals 4. Now you have to get this division 2 from left to right. Division 2 becomes multiplication. Then 4 times 2. Then 4 times 2 is, children, 8. Question number 5. Question number 5. 2x plus 1 equals 8. If there are more than one mathematical operation, children, there is an order to remove. X is multiplied by 2 and 1 is added. First you need to remove addition 1. Then to remove addition 1, children, you have to get this plus 1 from left right. It becomes minus 1. Then when 2x equals 7, then x equals 7 over 2. Then x equals 3.5 or 3.5. Question number 6. Example number 6, children. 2x minus 1 equals 9. Again, two mathematical operations. You remove minus 1 first. minus 1 becomes plus 1, then 2x equals 10, then divide 10 by 2, 10 over 2 is 5, x equals 5. Question number 7, x over 2 plus 1 equals 6, x over 2 plus 1 equals 6. Right then children, x is divided by 2 and 1 is added. Then you get children, this addition 1 plus 1 from left to right becomes minus 1. Then x over 2 equals 5. Now get this division 2 from left to right, it becomes multiplication 2, x equals 10. Example number 8. Example number 8, x over 3 minus 1 equals 5. X over 3 minus 1 equals 5. Then children, here you have to get this positive minus 1 from left right. Then x over 3 minus 1 becomes plus 1. Then x over 3 is equal to 6. Then you get division 3 from left to right, it becomes multiplication, x equals 18. When x divided by 3 minus 1 equals 5, no? You get this minus 1 from left to right first, it becomes plus 1, 5 plus 1 is 6. Then division 3 from left to right, division 3 becomes multiplication, 6 times 3, 18. Right. Then children, example number 9. Question number 9. 2 times x plus 5 is equal to 14. Then divide both sides by 2. Then cancel this one. Now no need to put these 2 in a bracket. X plus 5 equals 7. Then x equals 7 minus 5. X equals 2. Last example question, 10th question. 3 times x minus 1 plus 5 equals 11. Here x is subtracted, 1 is subtracted from x, and the answer is multiplied by 3. 5 is added to this one. First you need to cancel children positive 3. To cancel positive 3, you have to get this positive 3 from left to right. Then write the remaining terms. 3 times x minus 1 equals 11 minus 5. Then 3 times x minus 1 is equals to 6. Now divide both sides by 3. Then you will get x minus 1 equals 2. Then x equals 2 plus 1, x equals 3. This is children how we solve simple equation. I again explain children how we solve simple equations. These will be help children to understand how we solve inequalities. We use the same procedure children to solve inequalities too. Right, now let's move on to the fourth subtopic in this lesson, solving inequalities. Subtopic number 4, solving inequalities. Solving subtopic number 4, solving inequalities. Solving inequalities. Right. Then question children, solve the following inequalities. Write the question, solve the following inequalities. First question, x plus 2 greater than 7. Use the same procedure children. X is greater than 7 minus 2. X is greater than to 5. Is it clear? In this case also you subject children x. To subject x, you have to get this positive 2 from left right. positive part becomes negative. If it is negative, it becomes positive, right? Example number 2. X minus 3 is equals to 8. Then x minus 3 greater than or equals to 8. Then x is greater than or equals to 8 plus 3. Minus 3 becomes plus 3. X is greater than or equals to 11. 8 plus 3 is, children, 11. Example number 3. Example number 3. 2x less than to 12. Now you need to get, children, this multiplication 2 from left right. You know, children, multiplication 2 becomes division 2. Then x is less than 12 over 2. X is less than 2, 6. Example number 4. X over 2 less than or equals to 4. Right, then, children, x is less than or equals to 4 times 2. X is less than or equals to 8. Are these clear, children? Then example number 5. 2x plus 1 greater than to 8. Then, children, 2x is greater than 8 minus 1. 2x is greater than to 7. Then x is greater than to 7 over 2. You can write this as a mixed number or a decimal number. Divide 7 by 2, 3. 2 times 3, 6. 1 is remaining. It is 3 and half. Or you can write down x is greater than 3.5. Both answers are acceptable. Question number 6. 2x minus 1 less than or equals to 9. Then 2x less than or equals to 9 plus 1. Then 2x less than or equals to 10. Then x less than or equals to 10 over 2. X is less than or equals to 5. Example number 7. X over 2 plus 1 is greater than to 6. Right? Then x, children, plus x over 2 is greater than 6 minus 1. X over 2 is greater than 6 minus 1. Then 6 minus 1 is, children, 5. Then x is greater than 5. Division becomes multiplication. No? 5 times 2. 5 times 2 is 10. Question number 8. X over 3 minus 1 less than to 5. X over 3 minus 1 less than to 5. Then x over 3 less than to 5 plus 1. X over 3 less than to 6. Then x is less than to 6 times 3. X is less than to 18. This is how, children, we solve, children, inequalities. Are they clear? Let's do few questions, few examples, few more examples. Question number 9. Minus 2x is greater than to 10. This is very important, children. Here you need to divide both sides by minus 2. No? You have to divide 2x and 10 by minus 2. There's something happen, children, when you multiply or divide by negative number. When you divide, children, a negative number like this sign should be changed. See, this greater than becomes less than. Minus 2x is greater than to 10. But when divide these two by a negative number, you have to change this sign. If it is greater than, it should be less than. And then x is less than to minus 5. I'll explain, children, this using another method. See, when minus 2x greater than 10, children, to convert this negative part into positive, you have to get this minus 2x from left to right. What happened to minus 2x, children, when you get from left to right? It becomes positive 2x. at the same time you get this positive 10 from right to left. Positive 10 becomes negative 10. Now see, minus 10 is greater than to 2x. It means children 2x is less than to minus 10. This can be written as children 2x less than to minus 10. Now you need to divide both sides by positive 2. When divide by positive 2, you will get minus 5. Then x less than minus 5. See, x less than minus 5. This happens when you divide children, when you change negative term into positive. But easy, if you do not use this method, children, use this method there, when divide by a negative term like this, you have to change this symbol or sign greater than symbol into less than. If it is less than, it should be greater than, right? Example number 10, minus 3x less than or equal to minus 12. Right, now you use this method, children. You divide both sides by minus 3. What happened to this sign, children? Less than becomes greater than. Less than or equal becomes greater than or equal. Now cancel this one. X children is greater than or equals to, then divide negative by negative positive 4. Then x, this one less than or equal, now it is greater than or equal to 4. X is greater than or equals to 4. Are they clear, children? Very important, children, to know how we solve inequalities. Of course, we use the same method, solving simple equation, same method to solve inequalities too. Right, now let's move on to, children, subtopic number 5. Subtopic number 5, finding the integral solutions. Finding the integral solutions. Finding the integral solutions. Subtopic number 5, finding the integral solutions. Finding the integral solutions. What's mean by, children? Integral solutions. Integers. What's mean by integers? Integers mean, children, integers. Integers mean, children, positive or negative whole numbers. Minus 3, minus 2, minus 1, 0, positive 1, positive 2, positive 3, dot dot and dot p dots. These all are, children, integers. Positive or negative whole numbers with 0 are integers. Now you are asked to write down, children, integral solutions. Only positive or negative whole number solutions. Right. Then example, write down the example. Write the integral solution set of each of the following inequalities. You write the question, children. You write example number 1. Write the integral solutions. Write the integral solution sets for each of the following inequalities. Number 1, children, first part of the question, x is greater than 2. Then what are the answer? What are the solutions? X is greater than 2. What are the positive, what are the whole numbers which are greater than 2? 3, 4, 5, 6. You can't write down all. No, this is an infinite set. So put few dots and put these in, children, curly brackets like this, because you asked write down solution set. No, sets are in curly bracket. Number 2, x is greater than or equals to 2? What is the answer? Equal or greater than to 2? Equal to 2 and greater than, then 2, 3, 4 and put few dots. Third example, x is less than to 2. Now x less than to 2. Less than to 2, 1, 0, minus 1, minus 2 and put few dots. Fourth example, x is less than or equals to 2. Equal to 2 and less than 1, 0, minus 1, minus 2 and put few dots. And this is how children we write down solution, integral solution set. Integral solution set. Right. Then children, let's move on to question number 2, example number 2. Write down example number 2, children. Solve each of the following inequalities. Solve each of the following inequalities and write down the set of integral solutions. And write down the set of integral solutions. First question, x plus 3 is greater than 5. First question, children, you are asked to solve this inequality. Then let's solve 5 minus 3, x is greater than 2. And this is the answer for solving this inequality. And then question says, write down, children, the set of integral solutions. The set of integral solutions. X is greater than 2. No? Then what are the possible answers? 3, 4, 5, 6 and put few dots. Example number 2. X is less than, x minus 7 is greater than or equals to minus 6. X minus 7 is greater than or equals to minus 6. First you solve this one. X greater than or equal minus 6. Minus 7 becomes plus 7. Then x greater than 7 minus 6. X greater than or equals to 1. Then what are the possible values? X is equal to 1 and greater than to 1. 2, 3, 4 and put few dots. Question number 3. 3 minus x is greater than 2 positive 2. Right, now you subject children minus x first. Minus x greater than 2. This positive 3 becomes negative 3. Then minus x is greater than to minus 1. You need to write down, children, you need to find x. Now to convert this minus x into positive x, you need to divide both minus x and minus 1 by minus 1. Divide both sides by minus 1. You know, in these examples I explain you, when divide a negative number, you have to change this greater than into less than. Then when divide minus x by minus 1, you will get x less than 2 positive 1. Then what are the set of solutions? X less than to 1, 0, minus 1, minus 2 and put few dots. Right, then this is how, children, we write down integral solution set. Right, then let's move on, children. Subtopic number 6. There are 2 more subtopics, children, in the lesson. Subtopic number 6. Subtopic number 6 is, children, representing the set of solutions, the set of solutions the set of solutions on a number line. Again children, the sixth subtopic, representing the set of solutions or solution set on a number line. You know children, about solution set. Now question says children to express the solution set on a number line. There are two methods children. We can express solution set and integral solutions on a number line. There are two different type of question children. We are asked to represent solution set on a number line and integral solutions on a number line. First question. Express the integral solutions. You write down the question. Express the integral solutions. Express the integral, only whole number solutions. Integral solutions in each of the following inequalities on separate number line. Integral solutions. First part of this question, x greater than 2. You draw a number line first children, a suitable number line, 0, 1, 2, 3, 4, 5, 6, 7 enough children. Put an arrow at the right hand side corner. X is greater than 2. What are the integral solutions which are greater than children 2, which is greater than to 2? Then integral solutions, whole numbers which are greater than 2 children, 3, 4, 5, 6, 7. According to this number line children, you have to color these points. You have to color children on the point, not above or below. On the point 3, 4, 5, 6 and 7. Example number 2. X greater than or equals to 0, 1, 2, 3, 4, 5, 6. Greater than to 2, equal to 2 and greater than. Then these are the integral solutions. If you are asked to represent children the integral solutions on a number line, you have to color these points. Then next type of question, second part B. Write the question. Represent the solutions or set of solutions in each of the following inequalities. Represent the set of solutions in each of the following inequalities on separate number lines. Right now question says to represent children set of solutions or solution set, not only the integral solutions, solution set, not only whole numbers but also decimals too. Number 1, x greater than 2. Again you draw a number line children, 0, 1, 2, 3, 4, 5, 6. Now x is not equals to, so you draw a circle like this. You draw a circle. You don't color this point children as x is not equals to 2 but greater than to 2 no. Then you have to color this point like this children. Is the method clear? Integral solutions you have to mark only whole numbers. Solutions you have to mark like this. Second part of the question, x equal or greater than to 2. Again draw the same number line, 1, 2, 3, 4, 5, 6. Now you draw a circle and you color that point also, because x is now equals to, and color children right hand side from this point to represent all the numbers which is equal or greater than to 2. Right? Then under this subtopic children, there are two different type of questions. We will be given children to represent inequalities, to represent integral solutions in an inequality and solutions set in an equality. There are two different type of questions. Right. Right. Now children, this part is over. Now let's move on to subtopic number 7. Subtopic number 7. Subtopic number 7 is children solving problems. Solving problems related to inequalities. The last subtopic, solving problems related to inequalities. In this type children, in this subtopic, we are not given the inequality. We are given children the question in words. We need to sometimes build up the inequality, right? Or sometimes we are given the inequality with a description. Right, now let's do this example. You write down this example children. Example number 1. Sakindu has 60 rupees. Sakindu has 60 rupees. Sakindu has 6 rupees. He buys a book for x rupees. He buys a book for x rupees and a pen for 10 rupees. Sakindu has 6 rupees. He buys a book for x rupees and a pen for 10 rupees. The total value of the item he bought can be expressed in terms of an inequality as x plus 10 less than or equals to 60. See, in this grade children, you will be given the inequality. Total amount that he has is children 60. He bought one pen cost x rupees and one book cost x rupees and one pen cost 10 rupees. Then the total cost of a book and pen is x plus 10, right? The amount of money that he had is enough to buy these two. Enough to buy mean may be equal or less than. It should be greater than, because enough, no, this money is enough to buy these two. Then this should be either greater than or equals to sum of these two amounts. Then solve this inequality and determine the maximum price that the book could be. Now question says children, two questions. First question to solve. Now let's solve this one. X less than or equals to 60 minus 10. X less than or equals to 50. This is how we solve. Then this is the answer for the first part of the question. Is solve. Question word solve. Then this is how we solve this one. Solve the inequality and determine the maximum price. There's another question. You ask to determine the maximum price that the book could be. Maximum price. What is the highest value that x can take? Highest value should be equal. If not, x should be less than 50 or equal. Then the highest value for x is children 50. Then the maximum price of this book. Therefore children, maximum price of the book should be 50 rupees. This kind of questions also given children. We learn this kind of question under solving problems related to inequalities. Right. In this lesson, children, of course, there are seven subtopics. I got children these seven subtopics to explain this lesson. Then lesson is over. But there are two more exercises. Two exercises. Exercise 21.1 and exercise 21.2. Exercise 21.1 children in page number 5 and exercise 21.2 is in page number 8. Page number 8. You learn this lesson children through this lesson video clip and do these two exercises, right? Repeat children. You repeat this video clip for several times till I understand the lesson, and hereafter children complete the two exercises. Okay, then this lesson and the description is over. I hope the next lesson next day. Thank you.